So we know, just I'll recap it. So we discussed about the difference between Spark and Hadoop, and uh, Hadoop is having its own storage called HDFS, and Spark is not having any its own internal storage, but it leverages the existing HDFS, and of course MapReduce both supports. But most of the people think that there won't be any MapReduce in Spark. It is a wrong conception. So we will have a MapReduce concept in Spark as well. And the speed, when it comes to speed, we have seen in the website of Spark, they claim that 10 to 100 times faster than Hadoop. And also resource management, yeah, it has its own resource management called standalone resource management, and it can also work on ARN resource management. So resource management, again, don't confuse. So when you're running an application or program, so the data resides on multiple nodes, and this particular operation needs to perform on each compute machine. So that's all. So to do that, so we need to know which worker node is free. All this information can be managed by ARN. So that is what. And we have seen, yes, Spark has its own standalone cluster, and also it can leverages the HBase, Amazon S3, and Hadoop's HDFS system. Okay, so
Okay.
then we have seen that yeah, Spark cluster, either you can set up your own Spark cluster, or else you can make use of Hadoop. That is a best practice where it will work on top of existing cluster also. So with that, you don't need to do a copy of data from one cluster to other cluster. That will be hectic for you. So you can make use of Spark cluster on the Hadoop. And then yeah, we have seen that it will leverages HDFS and AN. And yeah, it is not a replacement for sure. If you have already developed some MapReduce programs, you still can continue with that. But if you think that some programs are running very slow and you wanted to migrate them to Spark, then you can do that. And obviously, yes, it's an enhancement to the existing Hadoop system. It's not a replacement. And we have seen why we use, I mean, Spark especially. We have discussed like it is a in-memory computing, but every machine or every laptop, any calculator, if you take, they also work on in-memory only. But what is the specialty? So the specialty is distributed. So in-memory plus distributed computing is the unique feature of Spark. So that's what we have discussed, and then it addresses these two challenges where data scientists, they want to run a model iteratively in order to get out the accurate output, and also interactively data mining means like you need to have a faster data mining. It's not like you will first store the data and then you will set up some program and then you will run it for hours and then produce the output. It's not like that. They need instant results. For example, e-commerce websites. So these two areas, like, Spark has addressed the challenges. And then yeah, so that's what this diagram represents, that if you want to run a model, so we have a diagram here, you and Steve. So to connect these two people, of course mutual friends are available, Emily and Riley, but to know that we need to run at least 2 times a model. That's what degree of separation. So this is kind of example where, you know, Spark address challenges. Okay, then we have seen how MapReduce stores results when it is processing, and what is the disadvantage, and then where it comes, it will store in memory, not on HDFS. But end of the results, it will store in HDFS, but intermediate results, it will store in RAM. So it is not
Okay.
a new concept. That's what we told. It's not a new concept, but in memory plus distributed is something that different. Okay. Yeah.
Okay.
And yeah, so this is faster than Hadoop because it will prepare a logical plan and then physical plan, then it will split into tasks, then it will apply to a Spark cluster. That is the what you say, that Spark execution engine. So when people are asking about what are the features that are available in Spark, so you should not only mention uh, in-memory computing, but it
In memory.
has, yeah, Spark execution engine is something that very special than others, because Hadoop will execute its jobs on its own. Like it will not see for any optimization or anything. It will just run as is. But whereas Spark has its own execution engine. And yeah, core of Spark, we have seen resilient distributed data set. Charan, give me 1 minute. I'll just
Okay, okay. Sure.
So we have seen RDD also. So RDD means resilient distributed data set, and we will see more about it. So it is core of Spark, so which is kind of abstraction to store data, and it enables to track all the operations. That what we have seen. It will enables to track what transformation or what operation has done before. So we will see that
So
how
by abstraction to store data, what do you mean, Raja? Like
it's a collection
abstraction to
it's a collection of elements that you can store data. We will see how we can store the data. So
okay,
RDT holds the data. That's what resilient distributed data sets.
okay.
Okay, so then so it is Spark architecture. Yeah, so another advantage of Spark is its architecture. So it built in order to get the speed and efficiency. We will see when we discuss about this architecture. And
Okay.
yeah, these are all four features. One is in-memory computing, Spark execution engine, and then resilient distributed data set, and then Spark architecture. So these four will make a Spark as a faster and improves the efficiency. And these are all four core components. Okay, then yeah, RDD core of the Spark. Now we will discuss about RDD core of the Spark. Yeah, we discussed already. Yeah. So when
Yeah,
we
we
are
discussed
reading,
this
yeah,
already.
when we read the data from HDFS, so this is how it will create. And if there is any node failed in the middle, so we know that how fault tolerance will be picked up in HDFS. The
Yes.
same way we have discussed RDD in Spark. So how it will act. So we know that whenever a node fails, the other node will come and it remembers the operation. Yeah, this is what we discussed in the last session. So when Riley is not able to get the information from Sam, so what will happen? And another node will come, but that another node, how it will get, because we know that RDD or Spark remembers what operations have performed at particular node. So the other node will come and pick it up and then do the do the operation and then send the results to next node. That's what Riley. So this is what happened in
Okay.
RDD. Yeah, fault
Okay.
tolerance will be fault tolerance will be handled like this. And then now lineage. Did we discuss this? No, right?
One second. No, Raja.
Yeah.
I
So
don't remember discussing this.
yeah, exactly. So now here, what I'm doing here, lineage. I mentioned the term lineage. We will discuss how it works. For example, if you see first four lines of code, you know don't worry about all the terminology SC or underscore, but these four lines of code, what it will do, it will first read the data from a HDFS file, and secondly it will filter for error. Okay, and it will also filter for HDFS, and finally it will give the count. So now what I wanted to demonstrate here, so when you perform these four lines, when you execute these four lines, so if you see the lineage, first text file will be loaded into log file RDD, and then log file RDD again filter operation will be applied on this particular log file RDD, and then will create errors. That is another RDD. So finally it will filter for again HDFS, and then it will store into HDFS path. So that's what lineage. So for example here, for example here you have a log file and then errors you filtered out. Okay, here you filtered out errors. So now if the node fails here, so the other node will come and understand the operation here, and then it will again rebuild the error RDD. That's how, because it is a lineage, it will execute linearly. It is not executing in
Okay.
parallel. It will kind of a sequence. If in our terms, it is kind of a sequential execution.
See.
So if
Okay.
particular RDD fails, the other node will come and then the same operation it remembers, and then it will complete the process. So that's how it is resilient. So lineage will help us to get back if any node fails. That's what happens. Okay. So now
Okay.
that is what the difference. Sorry, definition I want to give.
So you
Resilient.
say like it goes in a sequential
Yes,
pipelined manner.
exactly. So rather we use the sequential keyword. We will use
Okay.
lineage. Okay. So here that's what R stands for resilient. So a resilience, how you will achieve by referring to that. Say for example, here one more example I have given. It is not visible here. Same example in the previous one. So in HDFS file we have, then we have a log. Sorry, this is for errors, and again this is for errors. Filter option, filter option, and then HDFS finally, and then we are using count. So if some node, for example, if this node fails, node 1, node 2, and then 5, and then here again node 1 to node 5. So for example, node 2 fails. So what will happen? The other node will come and then perform this operation, and then results will be sent to this particular node in errors RDD. So this is
Okay.
in-file RDD, errors RDD, and then HDFS. So that's how we will execute. And what is distributed data set? Now the data is being distributed across nodes, right? So that's why it is
Yeah.
called as a distributed data set.
Okay. So
Okay,
RDD 1D means the distributed means the
yeah,
data is actually distributed across
distributed,
the node.
yeah,
This way
exactly.
distributed.
Data set,
And having a being in a sequential fashion, having this fault tolerance kind of thing
yes,
is
that is resilient.
resilient.
Exactly,
So it combined collectively we call it as RDD.
RDD, exactly.
Okay.
Okay, yeah. So properties of RDD is something that property one is list of partitions. So Spark will know how many partitions are available in that particular scenario. For example, we are reading a file, right? So now five
Okay.
partitions are available. So five partitions, Spark will have to, I mean, it has to have information about all those partitions, because if some partition get lost, it has to recover, right? So that is property of Spark. And other one
Okay.
is comp
Partition means the distributed data, right?
exactly. See here, this is input data. Here it is input data where HDFS file is available, and you know that the blocks, it's split into blocks. So 128 blocks. So how many blocks are available? So by default it will create those many partitions.
Okay. So sorry, please can you explain that again? I'm
Yeah,
sorry.
see nothing. See, a file is split, like for example 1 GB file is available.
Okay.
Then each block size on HDFS is 128 MB. So 1024 divided by 128 MB. So these many blocks will be available like that. So these
Yes.
blocks, when you are applying your program, Spark program, so those many partitions will be created here on the nodes. So node 1 to node 3. So these many partitions will be available.
Okay. So the number of
See, when you are reading,
partitions.
see when you are reading the HDFS file. So say for example, this particular HDFS file is split into number of blocks, and the blocks are available in particular nodes, for example. So those will be calculated on same, like it splits into number of blocks, and they are available in each different node. So node 1 to node 5.
Okay.
So as is, when you are reading this particular file, which is available in HDFS using sc.text file function. So it reads the data from each block and each node, and then the same partition will be created on each particular node.
Okay. So each node is associated with a partition for that
Yes,
particular
correct,
function or something.
correct.
Okay. So
So
it will essentially it will be equal to the number of nodes, number
exactly,
of partitions.
exactly.
Yeah. Got it.
So now Spark has to remember list of partitions. That is one thing, and Spark will remember what compute functions are performing at each level. Okay, and the other one is list of dependencies. So list of dependency means, if you see here, I'll just go back to the previous slide. What is the dependency? So if you see here, this particular RDD is dependent on log file. This particular log file is again dependent on this one, HDFS file. Okay,
Yeah.
this is what a dependency we call it. So it also remembers the dependency.
Okay.
Okay, for example, if you see here, node 3 here in errors RDD is dependent on node 3 RDD in HDFS file RDD. So similarly
Okay.
here this particular, I mean, each one is dependent on previous operation. That's what dependency we call it as.
Okay.
Okay, so it has to remember list of dependencies and compute functions and list of partitions. Then only it can calculate in case of any failure, right? Any node failure, so that it will remember what needs to be done there. So that is the
Okay.
concept of RDD. Then here, if you see here, I have a one file like from 1 to 4, block 1 to 4, and then some code. I will show you the sample file later, but just remember it is not visible here. So which is a text file, and this is stocks, and then I'm splitting into using map function, and I'm going to split it again using map function, and then symval, and then maxval. So the file is, I'll show you. Okay, yeah, let me see first. Yeah, nothing. This is the symbol, and then the date, and then high low, and then some attributes. We will
Yeah.
see that. Readme. So it is something that like this: exchange, and then symbol, and then date, open, high, low, close, like that. So here
Okay.
I'm reading that particular file, and then stocks, it will become stocks directory, sorry, stock RDD, and then I'm using some map, and then I'm going to split it, and then again I'm going to split it one more time, no, map it one more time to get only symbol and then value. For example, from here I'll be retrieving the information symbol and then value. So it has open, high, low, close, value. So this is the value one. So I'm
Okay.
going to pick it up only those two columns. That's all, to perform the max val. So max val means among those, again, I'm going to calculate what is the maximum value for that particular symbol. So that is the
Okay.
operation. So what will happen? So from here to here, stocks RDD created. Again, I have created split RDD, and then symval RDD, and then maxval RDD. Now you can see here, we discussed about the dependency here. Before here, we told that property number 3, list of dependencies, right?
Okay.
So list of dependency, and then compute functions, and then list of partitions. Now what is
Partitions.
dependency? Yeah, dependency is something that, dependency, I will explain it now. This is important. For example, you have a friend, and you are required to borrow money of $100. Okay, so now
Okay.
this is called narrow dependency, because you are dependent on your friend for $100. So there is no choice for you in order to get the amount. So your friend has to lend money $100 to you. This is what narrow dependency. Now we
Okay.
will see the another case. Now when you have multiple friends, now you can seek 25 from each one. This is what wide dependency. Just leave about this Spark concept. This is what I mean, real-time example, just I'm explaining. So this is wide dependency, and this is narrow dependency. Now we will see how this will link to Spark. There is one more scenario where you have 50 $50 but you are getting the amount from first two friends only, but you need $100. Okay, so do you
Okay.
think it is a narrow or wide dependency? So this is not a wide dependency. Since you are getting multiple people, it will not become a wide dependency. It's still a narrow dependency because your friend is having 50 50 50 50. Four members are having 50 only. But this time you are expecting $100, and then first two friends you are expecting, and they have to give what they have, entire amount. So this is not at all a wide dependency, it is a narrow dependency again. Now you got the
Okay.
difference between wide dependency and narrow dependency. So likewise, so this is a high, this is a not a wide dependency, it is a narrow dependency. So now what does it mean? Why we are relating this with Spark? So depends upon dependency type, Spark Spark will create number of tasks.
Okay.
Okay,
Number of.
number of tasks.
Okay. Okay.
Okay, number of tasks will be created based on the dependency only. So this
Okay.
concepts, most of the people will not know, but we will discuss. So that's what. So when you have a narrow dependency, means like child partition depends on entire parent partition. That is what. Now if you see here one more
Okay. Okay.
example, same thing. So now here partition P1. So partition P1 inside splits. Okay, partition P1 inside splits. Okay,
Yeah.
it's is dependence on, sorry, one second. So partition P1 inside split is dependent on P1 RDD in, sorry, P1 partition inside stocks. So this is having narrow dependency because
Okay.
it has to process what it will come from stocks. Again, Symval also is dependent on, sorry, if you take some partition P2, partition P2 inside Symval is dependent on P2 coming from splits RDD. So this is also a narrow dependent. But when you see this Maxwell, this particular
Yeah.
P1, P2, P3, P4 in Maxwell are retrieving the data from multiple partitions because we are using reduce by key. So reduce by key is something that it's like a aggregate of aggregations. In SQL we have a max, min, average, right? Like that,
Yeah.
reduce by key will perform these operations, reducing by key. Okay, so now if you see here, this particular Maxwell is having wide dependency because it is not only depending on one particular partition, but it also expects from multiple because the shuffle will operates here. Clear?
Okay. Yeah. Yeah.
Yeah, so that's why
So
it,
actually, it is depending upon multiple parents.
exactly,
The data
exactly,
from multiple sources
multiple
are
parents,
multiple.
exactly. So it is not depending on a single RDD. Okay, so
Okay.
that's what we call as a child partition. Why? When we call it as a narrow dependency, child partition depends on entire parent partition. And wide dependency is something that child partition depends on a partition of each of the parent partitions. Portion of each of the parent partition. Okay,
Okay.
yeah. So now we will see one example here: RDDA, RDDV, and RDDC. So now it is a kind
Okay.
of a,
So if I can all like, I'm sorry.
yeah,
So for wide dependency, portion of each of the parent, right?
that's what.
So is it like each of the when you say each of the parents, are you meaning that multiple parents or all parents?
Multiple, see, it is not necessarily required. For example, you have India sales and Singapore sales and US sales. For example, when you are dealing with this data, so partition 1 may contain India data, partition 2 also may contain, partition 3 also may contain, sometimes partition 4 may not contain in this level. So what will happen when comes here, when we are doing reduce by key, so all India data will be come to one partition. So now if you see that that particular partition is P1. So P1 is handling India data, means like shuffling happens and then it collects all the information related to India. Now it is not necessarily rely on the P4 partition, right?
Okay.
Okay, so it can just get the data from P1, P2, P3, or else sometimes the less amount of data is available, only P1 partition itself handles the data, like for Singapore sales. So in this case also, it can go to any of the partitions available in this Maxwell RDD.
Yeah. Okay.
Okay,
Makes sense.
so wide dependency is something that it expects a portion of data from each parent partition, whereas
Okay.
in narrow
Uh,
dependency
so if you can go to the money example again,
yeah
uh, the money example.
yeah
Yeah, they are this. Yeah, let this slide.
okay
So here also like we are expecting, like we are not expecting from multiple people, but not
Exa-
expecting from all. But from
exactly
multiple people, we are expecting. Okay, we are not expecting a portion. We are expecting
exactly
some.
yes, so
Perfect.
that's why it
Yeah.
is a narrow one.
Okay, makes sense.
So remember why we are discussing this much for dependency. So based on dependency only, number of tasks will get created.
Okay, so not complete and just portion is the keyword there
Exactly,
in this
exactly,
example. Okay,
exactly. Okay,
thank you.
so that's how it will execute. So now we have a sample example over here, RDDA with ABC and RDDB with the XY, and we are using some Cartesian product. So this is also kind of a narrow dependency because each element it goes and then cross, it will perform cross and then generates the output of ax ay bx by cx cy. So this is kind of a narrow dependency. So finally we can conclude that, see, you can have a narrow dependency even when a child partition has more than one partition. That is what
Mhm.
to remember here. And as long as the child partition depends on entire parent partition, so that becomes a narrow dependency.
Okay.
Okay, so now why we are discussing this much dependency, right? Why we are discussing this much? These two are the reasons. So type of dependency determines the number of tasks to be created, and also type of
Oh,
dependency has an impact on fault tolerance. We know that fault tolerance. What is fault tolerance? Now I'll explain you what is fault tolerance. I think in the next slide itself we have some answers. Yeah, so here if you see dependency clear, I mean if you understand that, now we will explain about fault tolerance by using this slide. Now
okay.
stocks, sorry, I'll go to splits. So splits and then p2 partition I will concentrate now.
Okay.
When p2 partition in stocks here, say for example this got failed. Now what will happen? Spark remembers the operation, right? And then it will run this particular portion of the code by taking the help from other compute machine. So that is the concept. So here, this is since it is a narrow dependency, of course, the execution of, I mean, the re-execution will be like one time only, right?
Okay.
So what I mean to say, since it is a narrow dependency, so P2 is actually operating on the output of this P2, stocks P2. So splits P2 is dependent on stocks P2,
Yes.
right? And say for example, you can say task 6. And when it failed this particular P2, it will again run the same operation using the other node. So fault tolerance will be
Yes.
recovered and then P2 will get the data and then process it and then proceed further. So now what will happen? For example, here in this P2, okay, this particular P2 got failed, which
Okay.
means Maxwell.
Yes.
So
Which
Maxwell,
is the
this,
wide
yeah,
dependency. Yeah.
yeah, which is wide dependency. Now, when P2 fails, now imagine this is not a depend on only this particular symbol, but also
Yes.
on all this. So now what will happen? It has to run all the operations involved here.
Okay.
You mean you got it, Charan? Say for example, here
Yeah.
only
It
one
should
operation
again
is
run the.
because yeah, when P2 get failed, other node will come, but other node
Yeah.
will not get the exact output of these four, right? So now what will happen? It
Yes.
has to run entire operation again.
Yeah. I mean, like you mean like from stocks P to
Exactly,
splits P.
exactly. Stocks P2, splits P2, symbol RDD. So like that, then only it will get the information. No, no, no. It's not only depends upon P2 level. It is because it is getting data from multiple partitions. So all partitions will be executed again. from stocks, split, and then symbol.
But why do we need to execute all partitions again? Because like in other nodes, we do have the intermediate result ready, right?
Exactly. So that's what here P2 node, sorry, P2 is the partition which is available in Maxwell RDD. Now say for
Yeah.
example, this got failed. So now
Okay.
one more node comes here and then it needs to execute all these operations. What happened here? Because
Only
it
the only that layer, right? Only like
exactly.
only the symbol layer.
Yes. Symbol, all these layers needs to be executed
Okay.
because it won't remember the operation, right? So a new node comes here when it fails, then it has to collect the information from previous, but it doesn't know what happened here. So that's why again it will expect to execute it again and then gets the data to P2.
Okay.
So that's what dependency. So wide dependency and narrow dependency. So
Okay.
we'll go to the next slide. So too many tasks, and again one more thing to remember, if you create too many tasks, again we need to store a lot of intermediate data and it will lead to poor performance.
Yes.
Okay, that is one thing. So now how we can address it? So that's what how we can address it. For example, if you see now here, if you see block line highlighted, black arrow mark, so how it would be if one task can handle entire set, like reading a file and then creating a stocks RDD and then splits RDD and then symbol RDD, then followed by Maxwell. So on node 1, task 1, the same way entire operation will be carried by task 2 on node 2. So how if we create like this? So that's what we call it as something like pipeline, creating a pipeline. So how that works, I'll explain about this one more time. So without pipeline, with pipeline. So what is pipeline? So pipeline is something that if you see here, without pipeline, how it will be, you will have a data set and you are reading stocks, okay, stocks RDD, and then P1 partition you are creating. So you are applying some map function. So what will happen, this particular map function will be applied to all the elements iteratively, and then it will move forward to the next layer. Again splits are already created, and here again we are applying map function, and then that map function will be applied iteratively to all elements, and then it will perform, then transfer to the next layer. So this is something that without pipeline. Okay,
Okay. So yeah. So it like for each
element
like
for
for each node and all, it again does the same thing for all the data, right?
exactly
Redundant work.
redundant work. So now with the pipelines, what will happen? So every time it executes one time, that's all, and then performs the operations and then send the data to the next layer. And then if at all, if it is required to read something again, so no, what I mean to say, rather repetitively performing this operation. So this is how pipeline will build, and then you read the data and then you will process the data in P1, which is a target. Again, if you are reading a new block, you don't want to create it, sorry, you don't want to repeat it again and again. You will just run it one time when you create a pipeline. I'll tell you what is pipeline in the next slide. So here you are going to split this into stages. So all these operations from here to here, it will create one block called stage 0, and then the remaining reduce key functionality it will create into stage 2. So it will split up into two stages, stage 0 and stage 1.
Okay.
So this will reduces the number of tasks to be created. So earlier when we had one example, okay, when we had one example here, you can see here task 1 to task 4, again task 5 to task 8, and then task 9 to task 12. Again one more also, since here we are doing reduce by key, here also task will get created. So it will be almost like 12 plus 1, almost 13 tasks. Now when you create like this stages, so from here task 0 to task 3, and then task 4 to task 7. So total 8 tasks will close this operation.
Uh-huh.
So the Spark will split into all this. I mean, stage is something that group of tasks.
Okay.
So what will happen here? Now stage 0 will perform entire operation, which means task 0 will handle entire operations from data sets to symbol functionality and then keep it ready. And in the stage 1 layer, task 4 will take that particular output from all these operations and then do the reduce by key operation. So
Okay.
now here creating and sorry number of tasks here is reduced like anything, only 8. But in the previous
Uh,
example we have
but actually, the execution, the flow is the same, right? We are doing block one text file map reduce by key.
exactly.
What is
So
this task essentially again? Like,
sorry.
what is like ex- eh, essentially what the execution what is happening is the same thing, right? The distribution of data and what all are
Exactly.
happening is
So now
what.
exactly. So now what we are trying to achieve here is to reduce the number of tasks. So here, if you see at each layer, yeah, what I mean to say, at each layer, a task will get created. See, to read the data from block one and then to create a RDD stocks RDD with P1 partition, we required one task.
Okay.
Okay, like that, we need to have a 1 to 4 tasks because we have 4 blocks. And then task 5 to 8 in order to create a splits RDD with 4 partitions. Again, we
Okay.
have 4 partitions to create symbol RDD with 4 partitions.
Okay.
So now too many tasks will have a lot of intermediate data and then poor
Yes.
performance. So now what we are trying to do is the Spark will have a pipeline concept where we will not iteratively do these operations. We can make it to carry with one task. So to do that, so we can create stages. That's what my intention. So when we split this up into stages, so in the stage 0 and stage 1, we have 2 stages. So task 0 itself will takes place from B1 to this P1. You're getting what I'm
Yeah.
saying? See, so we can set such a way one task can handle end to end rather creating one more task here, one more task here, one more task here. Just we can set in such a way task 0 will handle data which will include reading the data and then performing some map
Okay.
operations
What we
again.
are doing is we are essentially doing the same operations and
Yes,
every
but achieving through yeah reducing
but we
reducing
are not generating intermediate results after each small thing. We are generating an
exactly
intermediate result
yeah
once and for all the
exactly
maps and all.
exactly correct. So we don't want to do that. We don't want to do that at each level by repeating. I mean, too many tasks. We are not creating too many tasks. One task will handle that.
So the intermediate result which will be in the thing is like complete at the end of once and for all. At the end, we'll
Correct.
have the intermediate result stored. Okay.
Each RDD, yes.
Meanwhile, we don't store any intermediate results anywhere.
Correct.
Okay. Okay.
Okay.
No.
So
Yeah.
don't confuse. It will still confuse, yes. But when we go for actual hands-on, we'll get to know. So this is just
Yeah.
a concept that I wanted to introduce. Okay. So now task 0, task 1. Yeah, this is what happens. So stage 0 and stage 1. So task 0 will perform on node 0. Task 1 will perform on node 1 and task 2 will perform on node 2. So like that
Okay.
single I mean now for each node only one task and it will carry the results still here symbol and then task 4 on node 4 will take the data from all these partitions and then it is a kind of a stage 1 block. So we split it into two blocks, stage 0 and stage 1.
Okay.
Okay. Okay. Yeah, I think that's all. Yeah, so execution in Spark, this is how it will execute. So we have seen number of number of partitions that created after applying this dependency. Yeah, so important thing that I wanted to demonstrate here is Yeah, dependencies, how they play role while creating a number of tasks, and how it will
Yeah.
act as fault tolerance when we have a too many dependencies or less dependency, how the fault tolerance will act. Okay.
So creating dependencies like number of tasks is like if we
Exactly.
have a narrow task or sequence of narrow tasks, we can actually
Yeah.
combine that into one small task, like one
Yes.
only one single task, and
Yep.
we can have set
Yes.
yeah, getting understanding things. Yes,
Yeah.
like
Yeah. Yeah. Okay, so we'll stop it for now and then we'll continue next session. We will start with the hands-on, how these RDDs will get created, how we can create, what are the ways. We'll discuss in the next session, Charan.
okay, okay, sure.
Yeah, all right. I'll stop.